Ever looked up at the night sky and felt a sense of wonder, a feeling of being part of something vast and incomprehensible? What if I told you that the deepest, most mind-bending mysteries aren't just out there in the cosmos, but right here, inside every atom, every particle that makes you you? Today, we're diving deep into the quantum realm, to a place so strange, so counterintuitive, that it has left even the brightest minds like Einstein feeling deeply unsettled. This is the quantum secret that whispers a terrifying yet awe-inspiring possibility about the very nature of our reality. Let's start with something you might have heard of, the double-slit experiment. It's the rock star of quantum physics for a good reason. Imagine firing tiny particles, like electrons, at a screen with two small slits in it. If these electrons were like tiny billiard balls, you'd expect to see two distinct lines on the detector screen behind the slits, right? One line for each slit. But that's not what happens. Instead, we get an interference pattern, a series of multiple bright and dark bands, just as if waves were passing through and interfering with each other. This means a single electron somehow acts like a wave and passes through both slits at the same time. It exists in a state of multiple possibilities, a superposition, until we measure it. Now, here's where it gets really weird. What happens if we try to peek? What if we place a detector at the slits to see which one the electron actually goes through? The moment we do that, the moment we observe its path, the game changes. The interference pattern vanishes. Poof! We're back to just two lines, as if the electron suddenly decided to behave like a well-mannered particle again. It's as if the universe knows we're watching. The very act of measurement, of gaining information about the particle's path, forces it to choose a single state out of all its ghostly possibilities. This is called the collapse of the wave function. Think about that. Our observation seems to fundamentally alter the outcome. It's not just passively recording what's there. It's actively participating in creating the reality it measures. This is the measurement problem, and it's the elephant in the quantum room. How and why does our observation cause this collapse? What separates the fuzzy, probabilistic quantum world from the definite, classical world we experience every day? Physicists have been wrestling with this for a century, and there are no easy answers. This is where we step from strange science into territory that can feel downright terrifying. One of the first major attempts to explain this was the Copenhagen interpretation, championed by Niels Bohr. It basically says, that's just how it is. Don't ask what the quantum world is doing when you're not looking. The math works, so just shut up and calculate. It posits a divide between the quantum system being measured and the classical observer doing the measuring. But this is deeply unsatisfying. Where is that line? Are we, as observers, somehow special? Does our consciousness have a unique role in collapsing the wave function? This idea that consciousness creates reality is a rabbit hole that has fascinated philosophers and scientists alike. While most physicists today don't subscribe to it, the problem it tries to solve remains very real. Now, let's explore an even more mind-bending idea, the many worlds interpretation, proposed by Hugh Everett III. This interpretation takes the math of quantum mechanics at its word and follows it to its logical, albeit shocking conclusion. It says the wave function never actually collapses, ever. Instead, every time a quantum measurement is made, every time there's a possibility for multiple outcomes, the universe itself splits. In one universe, the electron went through the left slit. In another identical universe, it went through the right slit. Every quantum event, happening trillions upon trillions of times per second all across the cosmos, is constantly branching reality into a near infinite number of parallel universes. Let this sink in. According to this theory, there is a version of you who decided not to watch this video. There's a version who became an astronaut. There's a version where dinosaurs never went extinct. Every choice you've ever made, and every choice you didn't make, has been played out in some parallel reality. You are just one version of you on one branch of this immense, ever-growing cosmic tree. The you in this reality can interact with the others, but they are just as real as you are. This isn't just science fiction. It's a serious scientific proposal born directly from the equations that govern our world. Is that terrifying? The idea that countless versions of you exist, living out every conceivable permutation of your life? Or is it comforting, knowing that somewhere, a version of you made all the right choices? But what if the problem isn't with branching universes or conscious observers? What if the issue is that our understanding of reality is missing a piece? This is where theories like pilot wave theory, also known as Bohmian mechanics, come in. Championed by David Bohm, this idea revives a concept Einstein was fond of. It suggests that particles are always particles. They have definite positions at all times. We just don't know them. What we perceive as a wave of possibilities is actually a real, physical pilot wave that guides the particle's trajectory. So, in the double-slit experiment, the particle goes through only one slit, but the pilot wave goes through both, creating the interference pattern that guides the particle to its final spot. This sounds much more reasonable, right? It restores a sense of order, of a reality that exists independently of our observation. But it comes at a cost. To work, this pilot wave must be non-local. This means it can influence things instantaneously across vast distances. Information about the entire experimental setup, including the other slit, is instantly available to the particle via its pilot wave. This is what Einstein famously called spooky action at a distance. It violates our classical intuition that nothing can travel faster than light. So, you can have a definite local reality that only exists when you look at it. Or, you can have a definite reality that's always there but is connected by spooky, instantaneous, universe-spanning threads, which is more terrifying. So what is the great quantum secret? It's not just one thing. It's the profound, unavoidable conclusion that the world we see is not the full picture. It's that at the most fundamental level, reality itself seems to be either probabilistic, splitting, or spookily interconnected in ways that defy common sense. The secret is that observation is not a passive act. Whether it's through collapsing a wave, selecting a branch of the multiverse, or interacting with a non-local pilot wave, the act of knowing seems inextricably linked with the act of creating. This isn't just an abstract philosophical debate. This has real-world implications. Our entire digital age, from computers to smartphones, is built on our understanding of quantum mechanics. And as we push the boundaries with quantum computing and quantum cryptography, we're getting closer and closer to being able to manipulate these strange properties directly. We are learning to speak the language of the universe at its most fundamental level. The terror, if you want to call it that, comes from the shattering of our most basic assumptions. The idea that solid objects are mostly empty space, that time and space are not absolute, that a cat can be both alive and dead until you look. Quantum mechanics forces us to confront the possibility that the universe is far stranger, more mysterious, and more deeply connected to our own consciousness than we ever dared to imagine. But with that terror comes an incredible sense of wonder. We are not just passive inhabitants of the universe. We are active participants in its unfolding story. We are the universe's way of knowing itself. The secret isn't something to be feared, but something to be explored, a door to a deeper understanding of everything. Thank you so much for joining me on this journey into the quantum unknown. If this blew your mind, please hit that like button and subscribe for more deep dives into the mysteries of science. What do you find most fascinating or unsettling about the quantum world? Let me know in the comments below. Stay curious, and I'll see you in the next one.